Hello, I am the programming Dunce, and today I'm going to go over basic variables and the mathematical operations you can perform on them. Each variable has three main components: name, type, and value. The name is what you call it in your code. The type determines what kind of data it can hold, and possibly its range of values. In languages such as C, C++, Java, and C#, you declare a variable by typing in its type, and this means that this variable will, for its lifetime, remain as that type. This is known as an explicit type. However, there are implicit types as well, and they are predominant in languages like JavaScript and Python. In JavaScript, you declare a new variable with the keyword var and assign the variable anything. It could be a number at first and then become a string or another object later on. I prefer languages with explicit typing because I know what kind of data I'm working for with any given variable. I also love when my IDE, when working with complex objects, can provide a list of methods and data I can access, which can't really be done with implicit variables. C++ has integers, floats, and characters, which can be long to store larger numbers or short to store smaller numbers and use up less memory. They can also be signed, meaning they hold negative numbers, or unsigned, meaning they hold twice as many positive numbers but no negative numbers. I leave a link to a C++ page with all of the basic types available without header files. As an interesting note, when I learned Java, variables did not have signed unsigned, but I believe this was changed in Java 8. Characters, when neither signed or unsigned, can be used to store characters you might find in text rather than numbers, although each character is mapped to a numerical value. Because the majority of basic variables are really numbers, you can actually perform mathematical operations on them. For instance, plus can be used to add numbers together. Minus does subtraction. The star, Shift 8, does multiplication. Slash and the percent both do division actually. Slash returns the base value and the percent returns the remainder. You can include CMath to do more complex mathematical operations, such as finding the power, cosine, square, etc. Let us now turn to some actual code and see these operators and functions in action.
If you decide to use C instead of C++, you would use math.h instead of CMath. Also, since I'm using code that works for C and C++, I have replaced the C++ exclusive iostream with the C version stdio.h and use the function printf instead of std.cout. I then declare some global variables. This means that I can reference them from anywhere in the CPP file. This is because the scope is global. Scope is best viewed as surrounded, encased in curly brackets. When global, they are not encased. In main, we declare some more variables. These variables have the scope of main, meaning they can only be used after declaration and within main. After assigning variables, I print their value to determine that they do have a value. You'll notice that some variables have a type surrounded by parentheses. This is a process called casting, and for basic variables, this should be sufficient. You might want to do this if applying an operation to variables of a different type. For instance, I'm casting a double as an integer for this operation. This means that I can actually get an integer rather than a double, and the decimal portion is cut off. Here I have Here I have a function from our math library in use. I'm just using simple functions whose purpose is well known. In POW, we provide the base value 2 as the function's first parameter. The second parameter, 4, means that we will get the fourth power of our first parameter. Last but not least, I have a basic order of operations in source code to be printed. I use parentheses to organize which operations apply first. In general, the order of operations in source code is the same order seen in basic arithmetic. I am actually running this right now, and you can see the results in the white text and the black background. Hopefully, you can compare the printf statements to what's printed on the console, and you can pause the video if you have to. In the next video, I go over functions. In the video after that, conditionals and loops, because most code depends on certain conditions being met. Thank you for watching, and I hope to continue soon.